So the following is AP Biology, College Biology, covering the course Unit 1, Chemistry of Life, Elements of Life. So this is section 1.2. Please note that disclaimer here that AP Biology is a registered trademark, which means that they are a part of College Board and they don't have any involvement in the development of the products listed here or in the description with the additional products as well. Okay, so let's talk about what you need to know for AP Biology, specifically for this section. Unit 1 in general is really focused in on how to take biology and then mix it in with chemistry, or in higher level classes, they call that biochemistry. So you might see terms that you've seen before in chemistry. Please note you just need a brief overview of what we're going to talk about today, but it is helpful when trying to tackle nitty-gritty topics that come in later in the chapter. So we know that all living things consist of matter. So matter is anything that we say that occupies space and has its tendency to have mass to it. And we know that matter contains atoms. So this is a picture of an atom here. And an atom has inside, in the very center, which we call the nucleus, protons and neutrons. And protons start with the letter P, so they're going to be positively charged. They're designated by a plus symbol. And then you have neutrons, which are considered to be neutral. So you could see that in the root word there. So they're not going to have any charge whatsoever. And then on the outside, you have these, what they're called energy shells, which are these circles. We see one circle here, and that's where the cloud, the electron cloud, tends to resonate. So it's not a perfect circle, but for the purposes in most pictures, they make it look like a perfect circle just to let you know, hey, it's outside the nucleus. And what's outside the nucleus are these negative charges or these electrons. So please note that for the purposes of biology, you will need to know what atoms are, you will need to know what they contain, and you also need to know that atoms are in any form of matter, which includes solid, liquids, and gases. So a brief chemistry review. We have atoms, so those are the foundation or the building block of everything. And atoms are made up of elements. So if you see the word carbon, carbon is an element. It's an element, and how you know it's an element is you could directly find that element on the periodic table. So this is just a mock-up of a periodic table here. And if you have two or more elements, they can make up a compound. So for example, if you have hydrogen and then chlorine, then they can make what's called hydrochloric acid, and it has hydrogen and chlorine in it. A more complicated one of a compound is something like this, which has some oxygen. The little symbol here, just as note, is carbon. So anytime you have a bend in a shape like this is going to let you know that this is a carbon, which you don't need to know now, but you will need to know later on in Unit 1 and later on when it comes to AP Biology. So if you haven't taken chemistry before, just note that while there's no C listed in any of these bends, there are C's here, which means carbon. And these symbols here indicate double bonds. So the two lines, 1, 2, indicate double bond. So this is a double bond, this is a double bond. And that just means that there's two connections. They're more tighter than a single bond. And so that's something to note. And so all of these elements, so nitrogen, hydrogen combined together, that makes a compound and can formulate even bigger compounds. So two or more elements can make a compound. Now, if you have something breaking up or formulating, that could lead to some sort of reaction. So just to note that that could eventually lead to some reaction. A common reaction would be something like an explosion or something melting. Those are types of reactions that we would see. Okay, Now, when we're talking about energy and matter all together, we know that living systems, meaning everything around us, and you'll cover this later on in ecology, which is another unit on AP biology that you need to know, you'll understand that living systems require this change in energy, and we'll talk about that later on. But for now, you just need to know that there's energy and it's going to be a constant flow. It's neither created nor destroyed. It's just sort of going in and out in the environment. And a common form of energy is the word ATP. So if you see in biology, which we'll cover on later, ATP is your hint that there's some sort of energy nearby. So keep that in mind for the future when you need to understand energy in later units. Now, let's take a look at the atomic structure. This is not something that you're really going to be tested on, but you do need a foundational knowledge just in case you have a problem related to maybe an FRQ or multiple choice question. You need to know how to read the periodic table, which you probably already know if you've taken chemistry before, but we're just going to review it. So the first thing is the number up top is called your atomic number. And the atomic number is the same thing as saying proton. So I just have a P here. So anytime you think atomic number, think protons. Think that big plus sign because protons are positive. That's the number up top. Think it's positive. It's going to be up top because the more positive person or the more positive number is going to want to be up top. That's the way I can remember it. You have a symbol here that is called the atomic symbol. This just is your element on the periodic table. So in this case, it's Na, which is another way of saying sodium. So the atomic name sometimes can be listed right below. So you can see sodium here. And then you see this number here. This is called the atomic mass number. The atomic mass number, which you might need to remember, is the sum of the protons and the neutrons that are in the nucleus. And the way that I remember it is M equals A plus N. So you can think of man, and you might be thinking, what? So M is your mass, and it equals the atomic number that we know is also the same as the protons, plus your neutrons. So man. So if you need a mnemonic, just think of man as an easy formula to remember this. Okay, so now you're going to see in our AP biology coverage or college biology coverage this term isotopes, and you might be like, what are they? So isotopes are the same element, but it's represented by different number of neutrons. So there could be things like radioactive isotopes that are used in fossil dating or in medical imaging. A common example of this could be something used for thyroid detection. So that's where you would need to understand the term isotopes. So isotopes have different number of neutrons and they're the same element. So if you look on the bottom here, you could see that there's 3 carbons, C, 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 and they have the number of protons listed here, which are exactly the same, the 6. And they have the long form name here, but you see that there's differences in the designation here. You might be like, what is that? So the neutrons are different, which indicates that it is an isotope. And if you remember previously, we said man. So man is M equals A plus N. So if you had the same number of protons, but a different number of neutrons, this is going to change your mass number, which is what's happening here. All of these mass numbers are different due to their relative neutrons being different. So if you see some sort of value for AP biology where they give you the same element and then they go ahead and tell you, hey, there's the same element, but they have different number of neutrons, you're going to have to figure out that, hey, this means that these are isotopes. And for the purposes of AP biology, more than likely they're going to be talking about the topic of fossil dating or medical imaging. So just so you're aware when it comes to really critical thinking based problems. Okay, so we did cover this a little bit below in a previous screen, but I wanted to cover electron shells. So remember we said there's an electron cloud, but we designated as these like circle-like symbols here. And what that means is the electrons can occupy these energy levels or shells that are around the nucleus. Electrons are your negative charge, and they're going to move from a lower to higher levels depending on energy level changes. So that's important to note here because say, for example, there's an electron and it is either too high or too low, then it's going to shift to a different energy level, higher or lower, relative to what's available. So you need to know electron shells are outside the nucleus. They contain electrons, and different energy levels have different heights, so higher or lower energy levels, and they're going to change dependent on what's absorbed or what's being released. So electrons absorb energy to move to a higher energy level, and they release energy to move to a lower energy level. So that's important to note as well. Functional groups determine the properties and functions of molecules. The thing is, for AP biology, you're not going to give a word for word question as it relates to the structure. What I mean by that is they're not going to ask you a question like, what is the functional group of a C double bond O? And then you're going to have to label it as carbonyl. Instead, they're going to give you a molecule, more than likely some sort of macromolecule, maybe a carb, maybe a protein. And you'll see these structures listed here in those molecules. And it is really helpful to review this chart to help you remember the properties when you're going over or completing a very hard critical thinking question. For example, OH usually indicates some sort of hydrogen bonding because it has an O bonded to an H. So we know that it's going to increase in solubility. Another example is a carboxyl. And so carboxyls have this little H that's attached that often wants to either donate an H. And so that's going to make it acidic per se. Another example is an amino group. An amino group can be considered very basic, and the way that I like to remember it is it often has a nitrogen attached to it. And usually when you have a nitrogen attached in any molecule, it indicates some sort of protein. Oftentimes it is in a really giant molecule. So it's helpful to recognize that. And for example, phosphate, which is a really strong property of ATP. Remember, we talked about energy. So seeing a phosphate like a triphosphate, that's what TP stands for, like T for triphosphate means that there's three phosphates. So if you see that PO symbol, oftentimes you're talking in terms of biology. You're usually leaning towards understanding that's ATP, which we now know is another way of saying energy. So it is helpful to review the structures, the functional names, and the properties alongside with it. You don't need to know the example, but it might be helpful to solve some problems. Let's try to see if we can answer some questions. Please note the following questions are not direct questions you'll see on the exam. Also note that chemistry of life in general for Unit 1 covers only 11% of the exam, and in fact is one of the fewer topics that you'll see as high yield, so it is considered a low yield section. With that being said, this is a great review when it comes to understanding the foundations of AP biology, as these concepts do come up in later units. So let's try to concept capture or understand this topic a little bit better. Let's take a look at this question. You're going to be asked the specification of the functional groups, and you're going to be asked to label the ones that are highlighted here. So take a moment, pause the video, and see if you can try to figure out what these functional groups are. Take a piece of paper or write it down, labeling what you think this one is, these are, and all the other ones that are labeled in blue. We'll review afterwards. Please make sure to pause the video now and then unpause when you're ready. Great. Now that you've completed this, let's review the question together. The following is the answer key. Some things to highlight to help you solve better is understanding different key indicators for the purposes of AP biology. If you see a phosphate, remember that that usually means that there's a P in there, and 85 to 90% of the time we're talking about ATP when it comes to biology and understanding the connection to phosphate. If you see a hydroxyl, that's OH. That doesn't just mean OH in the correct order, it could be HO as well. So the way that I like to remember hydroxyls is remember that it starts with the word hydro and oxyl, which can help you remember hydrogen and oxygen. So these are our hydroxyls. Just to circle around right here, there's an amino, amide, all of those have nitrogens in them. So take a look at when you're seeing that there's a nitrogen, and if you see amine, amide, that leads you to believe that there's an amino group. Self-hydrols, or thiols sometimes it's called, involves a sulfur. So that's seen here as well. Now, the best for last are these three here. The reason why I wanted to point this out is because carbonyl and carboxyl sound very similar. The only difference is the carbonyl only has the C and the O. You might be wondering, where is the C? Remember, anytime there's a little hook like this, the little bends indicate a C. So it's a C double bond to an O that you see for carbonyls listed here. Carboxyls are a little bit different because they do have the C double bonded to the O, but they're also attached to a hydroxyl. So they're going to be called carboxyl, sort of a mashup between carbonyl and hydroxyl. So you can see the beginning of a carbonyl, carba, and then hydroxyl ends in XYL. And then there's XYL here. So anytime you see COOOH or C double bond OOH, that should lead you to the term hypoxyl. Okay, now that you've conquered those, which are very hard, give yourself a pat on the back and try to see if you can identify this one. Take a minute, pause your video, and then unpause once completed. Okay, now that you've reviewed that and potentially answered that, this is a carboxyl as well, because you see the CO double bond to O, and then there's an OH. It's just identified a little bit differently. Now let's take a look at a different type of problem. It says they give you an element here, and you're asked to find the number of neutrons. And you're going to use some minor calculations, or you can estimate the answer, and then pause the video and then unpause once completed. Okay, now that you're done reviewing that question, let's try to review the answer key together. So you'll see here they identify the atomic number as 16, and then they let you know that the mass is around 32. We estimate the answer of 32. And remember that we have m equals a plus n. So we're going to take our mass, which is 32, our atomic number, which is 16, to then calculate the neutrons, and that's going to give you 16. So the neutrons in the nucleus are 16. I hope this helps, and if you like this video, please make sure to subscribe and like, and mostly make sure to stay in tune or stay in touch for future videos as it relates to AP biology. Thank you. Hey, you want to know a little secret? If you hit the subscribe button, you'll be able to get up-to-date information related to AP biology and the digital SAT math test. Making sure that you're able to understand the content is just the first step. So if you want updated additional information, make sure to click the link tree in our bio. We hope that you subscribe because each new subscriber gives us motivation to create more up-to-date content for you, students, parents, and teachers. Enjoy!